Every day when I wake up, I get myself a cup of coffee. That's what I do every single day. That means that I go to the espresso machine, push a button to get coffee, the machine lets me choose the type of coffee I want, then it automatically chooses how much coffee to grind, grinds it, and pressures water on it as much as needed, puts milk in it, and I get my coffee. I don't care about the specifics of how much coffee or pressure the machine uses to make my coffee, I just get my outcome. The machine is a black box to me as far as I'm concerned. This is abstraction, and that's the topic of this video. Abstraction is one of the four main principles of object-oriented programming. Let's get started. John V. Guttak said, "The essence of abstraction is preserving information that is relevant in a given context and forgetting information that is irrelevant in that context." So abstraction means that we're supposed to hide the specifics of how different works are done and make them abstracted into simple words. More precisely, when we're creating classes, we should make them in a way such that the class looks like a finished thing in and of itself. It means that it should provide functionalities that can be used in the rest of the program in a black box manner. Let's do an example. Suppose you're creating a program that uses a list data structure somewhere. Now suppose you need to have this list sorted at some point of your program. Abstraction says that this list you're working with should be able to sort itself, and it shouldn't be concerned with sorting and the algorithm needed for that in the middle of your program. You should be able to just ask the list to sort itself without worrying about which algorithm is used to do it. This is abstraction. Now, when you're creating a class in your program, you're practically introducing a new complex data type into the programming language. So your classes should be designed in that way too. That's what I mean when I say that in object-oriented programming, objects should be able to take care of themselves. Let's design a class so you understand what I mean. Since I started this video with coffee making, let's create a class to model our coffee machine. Let's say a coffee maker worthy of the name has three parts: the grinder, the brewing unit, and a milk system. We will make a class for each of them, and then we'll make a class for the coffee maker itself. Each of the classes that we're going to create is going to provide its own needed amount of abstraction. Let's start with the grinder. The grinder, of course, has a size, a fill percentage telling how much coffee it has inside it, and the obvious methods for encapsulation for it are set fill percentage, get fill percentage, get size, and the constructor, of course. Notice that I haven't provided a setter method for the size. And that's because once created, the size of the grinder cannot change. Now with that data sorted, I could already use it in a coffee maker. But abstraction says that I also have to provide some functionalities that are its most common functionalities for the bigger class coffee machine. So I'm going to provide some abstraction here as well. For that, I create two more methods. One is get status to tell if there is enough coffee left in the tray depending on the given amount needed. And the other one is, well, grind with amount as an input, and that is a method executed to start the grinding. It checks with the method getStatus to see if there is enough coffee in the tray. If so, it grinds the provided amount of coffee, and then it updates the fill percentage property of the grinder respectively. See, now all this work is abstracted into a single word, grind. Now my grinder class can maintain and take care of itself. This is abstraction. Now let's move on to the brew unit. It also has its properties like water tank size and water tank fill. Here again, we provide the obvious encapsulation methods. Those are get tank size, get tank fill percentage, set tank fill percentage, and the constructor to create an instance of the class, of course. The abstraction methods this class is going to have is just one, and that is brew coffee. As inputs, it takes provided grinded coffee, milliliters of how big the coffee should be, and the amount of pressure needed. It checks if there is enough water, heats the water, and presses it with the provided amount of pressure to make the provided needed amount of coffee. All of that work is abstracted into a single method called brew coffee. Moving on to the milk system. Properties and their respective encapsulation methods are alike and obvious. The abstract method is going to be steam milk that makes the milliliter amount of needed milk and the brew college as input, because it needs help from a brew unit to do its job. It checks if there is enough milk there. If so, it takes some water, heats the milk, heats the water, and steams the milk in needed amount. Milk and water fill percentages are updated afterwards. And now for the exciting part. we're going to create a class called coffee maker, and this is our actual application where we're actually going to use all that abstraction that we created earlier. Its properties are its grinder, its brew unit, and its milk system instances. It has only a constructor as an encapsulation method because none of the other properties are never needed to be set or get. It does, however, have a lot of abstract methods. One for each coffee specialty that the machine makes. As an example, I'll show the method for my favorite coffee specialty, the flat white. It gets the amount of needed flat white coffee as input. It asks the grinder to grind 1 ounce of coffee. It then asks the brew unit to brew 80% of the provided entire amount of coffee with the grinded coffee. It then asks the milk unit to steam 20% of the given amount of coffee in milliliters of milk. And that's it. A similar method can be created for other kinds of coffee specialties that we'll want to provide. Now, all of the work of making a flat white is abstracted into a single method flat white. And you get the idea. That's the power of object orientation. And that was abstraction. There's one more video in this series coming up. It's going to be about polymorphism, which is also pretty important. So stay tuned for that. Like, share, and subscribe. I'll see you in the next one.